Hello everyone. My name is Dhananjay Mishra, and today we'll be discussing, as usual, the problem of the day. So, before moving further, can you please let me know whether my voice is audible to you or not? Hi, guys. Uh, Welcome back. And so, before moving further, can you please acknowledge whether my voice is audible to you or not? Whether I am also visible to you or not perfectly? Okay. I hope my screen is shared now. I hope it's shared now, right? Okay. So I think we have not missed much, right? So we will, up till now, when my screen was not shared, we just only discussed the problem statement. I hope many of you have read the problem statement, right? So I will discuss the problem statement again. So basically, what the problem statement says that we are given an array of n size that is denoting the heights of n towers, right? And we have a positive integer k, and what we have to do, we have to modify the height of each tower either by increasing or decreasing them by k only once, right? So basically, this statement says that we have to modify the height of each tower. That means we cannot skip the modification in any of the tower. We have to modify each tower either by increasing its height by k or decreasing its height by k, and we can perform this operation on a tower only once, right? So after that, after modifying, one more constraint to put over us is here that after the modification, the height should not be a non-negative integer. That means the height should be greater than or equal to 0 after the modifications. And the task is that we have to find out the possible minimum difference of the height of the shortest and the longest towers after we have modified each tower, right? So after some modifications, we will obviously have a longest tower and a shortest tower, right? So we have to find the minimum difference between the longest tower and the shortest tower, right? So yeah, so let us now look at some examples, right? So in the first example, it is saying that 1, 5, 8, and 10, and we can modify each tower height by 2, right? And the output is 5. So how output 5 is coming? So this was our array, that is, right? This was our array 1, 5, 8, 10, right? So what we can do, we can subtract the height of the last tower by 2 and increment the height of first tower by 2, right? So it will come 3 and 8. But we also discussed that we cannot skip any towers modification, right? So to keep this as the minimum, because we have to find the height, the difference of the height between the maximum and the minimum. So we are keeping it maximum and keeping this as minimum. So to keep this as minimum and this as maximum, what we can do, either we can decrease its height by 2, right? So it will become 3, or we can increase it by 2 also, right? So in either case, 3 will remain minimum, right? So it will become 3, or it can become 7, right? If we subtract, it becomes 3, and if we add, it becomes 7, right? And talking about 8, right? So if I increase or decrease its height by 2, so if I subtract, its height becomes 6, and if I add, it becomes height becomes 10. So basically, you can see that no matter what operations we perform on these remaining elements, the minimum and the maximum element will be 3 and 8 only, right? So that's why the difference is coming out to be 5, that is 8 minus 3, right? I hope this is clear to you, right? The explanation of this test case is clear to you. If up till now you have any doubt, you can ask me, so we can move it further. Okay, so I hope no one has any doubt. Yeah. So now we will look at the approach how we will solving it, right? So one approach that is coming to our mind is that a naive approach is that we will pick each tower one by one, and for that tower, I'll be finding uh, the maximum height I can attain, right? Or one more thing we can do is that we will try to form that height of the tower as maximum or minimum, right? Because if we set the height of that tower by adding or subtracting as minimum or maximum, suppose if I pick one, right, and if I'm able to make it minimum, then I have to find for this minimum modified height, uh, okay, this minimum modified height, we have to find the maximum for it, right? That's why, because we have to find the maximum minus minimum, right? So this is the one approach, right? But it will take the time complexity of n square, because for each tower 2 into n square, because for each tower first you will make it or subtract it, right? And then for subtracting it you will check whether it is minimum or not. If it is minimum, then if it is minimum, then you have to check for the other element that can be the maximum, right? Closest one to it. So it is not a, a good approach to follow. Okay. So Vidya Raj is asking that in if I add 2 to 8, it will become 10, right? Okay. Okay. Yeah, Vidya. Right. So you're correct. I missed it. That it if we add 2 to 8, it will become 10, right? But we have to find the minimum answer. So if I increase it to 10, if I increase its height to 10, then what will happen? Our answer will be coming out to be 8, 10 minus 3, right? It is 7, but it is not the minimum answer, because minimum answer is 5. To attain that minimum answer, that's what I said, to maintain this 3 as minimum and 8 as maximum, we have to do modifications in the remaining part according to that, right? I hope it is now clear to you, Vidya. So what I said is that to keep 3 minimum as 8 and maximum, we have to do the remaining modifications in the remaining array, such that the modifications in those remaining element does not affect the minimum and the maximum element, right? So yeah. So okay. So now I hope the first approach or the naive approach is clear to you. So one more smart approach we can follow is that, first of all, we will sort this array, right? I will tell you why we will sort this array, right? So if I, this array is, I guess, sorted already, right? It is 1, 5, 8, and 10. But the case might occur that the if the array is not sorted, right? So for that, what I can do, I will first of all sort the array, right? So it will become 1, 5, 8, 10. In this case, it is automatically sorted. Okay. So Aditya is asking that can we sort the array in ascending and add k to first element and delete k from last element? Yeah, Aditya, you are right, but this won't fetch us the final answer, because in this case only, right? If you do that, in that case, that the approach you are saying will not always work, right? I will tell you why it will fail, right? In some cases. So let us now move to this approach. First of all, we will sort the array. Why we will sort the array? Because you can see that to if we pick the adjacent elements, right? The difference between these adjacent elements will be the minimum, right? And what if I say, if I pick the this element and this element, right? So obviously the difference between 5 and 10 will be much greater than the difference between 8 and 5, right? I hope you're getting the logic. So that's why we are sorting the array, so that we can pick the adjacent elements only, right? And what we are trying to do after sorting is that we are trying to, suppose if I am picking this element, right? So if I make this element as the maximum, so what do I want? If I make this after modification, if I make this element as the maximum, I am assured that if I the other element that I can make minimum, that will fetch me an answer, will be only its adjacent element, right? Why so? Because the logic says that we are subtracting the same amount k from every element, right? So if I subtract this k value from 1, or suppose if there was some other value, suppose there was some other value, right? Suppose 2, and if I subtract this value, k value, from 2, so it will be more on the left hand side, right? Or I can say, after modification, the changed or the modified 2 will lie far away from 8, right? But if I modified or subtracted k from 5, right, the difference, or 5, will be much more closer to 8 than in comparison to 2. You can assume it as a number line, right? So if I suppose have a number line, right, and these are my numbers, right? And for this element, if I subtract, for this element I want to find the closest element after subtracting k, right? So if I subtract k from this element, this will reach out to some this value, right? And now if I subtract k, the same amount k from this element, as it is more left to this element, right? More left to this element, it will be far, it will be automatically far more farther to this element, right? So that's why we are sorting, right? Because I'm assured that from the adjacent element I can get the nearest possible minimum or maximum to this element I'm finding to. I hope till now it is clear. If you have any doubt, you can ask me, because this question is based on pretty much intuitions and logic. Once I write the code, the code is very simple, but it is all about intuitions and how to understand this problem statement, right? So till now you have any doubts that why we sorted this array? Okay. Now coming out to the doubt of Aditya, right? He's saying that can we sort the array in ascending order and add k to first element and delete k from the last element? No. Let us suppose take an example, right? If I take this array 1, 2, 3, 4, 5, and 6. Now if I say to you that the value we can add or subtract is k equal to 1, right? So according to you, you add 1 to it, it will give us a modified value of 2, right? So it will be modified to 2. And now if I subtract 1 from it, it will give me 5. So according to you, the answer is 3, right? But no, answer is not 3. What if I say that, you know, uh, what I can do is I can add 1 to it and subtract 1 from it, right? So the answer will come out to be 1, right? Because the maximum element is 7 and the minimum element is, 6. Okay, this case is not following, but I hope you're getting the logic, right? That it is not sure or assured that it is not assured, because okay, let us forget this logic, it is not working for this case. But okay, I will take a general case, right? Suppose you are given some elements, right? Take some elements like this only, right? And the value of k is coming out to be something large, right? Because in this case the value of k was 2, and therefore the value of k was 2, it is lesser value, right? So the logic you trying to say, Aditya, is working perfectly for smaller values of k. But what if I take some larger value of k? So if I take a larger value of k, then you can see that if I let us take the value k equal to 10, I guess, right? I'm not able to get the correct test case for that, but I hope you're trying to understand what I'm trying to say, right? So if I add 2 and 10, right? So it will become 12. If I subtract 8 from 10, it will become what? 2, right? The difference is 10 here, right? But it might happen that if I add something like to value to this or to this value, so by adding this, the adding 10 to 3, it might reach much more closer to 8, right? So it is not sure that adding 1 to only the first element, adding this value and deleting k from the last element will fetch you the answer, right? I hope I'm clear, because I'm not able to get the correct test case for it, but I hope the logic is clear to you. Why we can't do that, right? Because I will repeat it again that it might possible for some larger value of k that if you can add something to a middle element and subtract from that element, you can still reach more closer to that thing, right? And one more thing is that in this case, let us take in this case only, right? Your maximum element, right? We assume that here only we assume that what if I subtract 2 from it, it was 8, it became 8 and it become 3, right? So 8 is still greater, right? But in this case the smaller value is becoming greater than the larger value, right? So if I subtract 2 minus 12, it will give me a negative value, so it is not the answer, right? It will not satisfy, right? You can try your logic and you will get the wrong test cases, and after that you can feel what is the wrong, right? Yeah, thank you, Aditya. I love that you got the logic. Vidya is now asking that after that, okay, so we will come on to your doubt, Vidya, after on, right? I hope up till now that sorting part is clear, why we are sorting, right? Now coming on to the logic, what we will do after sorting. So idea is that, let's take this example, right? The example is 3, 9, 12, 16, 20, right? So it is 3, 9, 12, 16, and 20. Now what I said that we are assured after sorting we will get the answer from the adjacent elements only, right? And we can't skip any of the elements, we have to modify them, right? So I hope it is clear that why we are sorting and why we are sorting, because for the adjacent elements, right? I will repeat it again that for this element I will get the answer, or some modified element having difference with this element will be smaller among all of these elements, right? Among all of these elements, the adjacent element will have the smaller difference for this element, right? So that's the logic. Let us now look how we will do that, right? So the first step is that first is the boundary case, right? First one is the boundary case. So okay, so if I don't modify any of the array after sorting, so what can be the worst answer I can get? The worst answer I can get is 20 minus 3, right? This will be the answer, right? The maximum answer I can get. It is not the right answer, but uh, assuming that it will be the maximum answer, or it can be the answer, right? So 20 minus 3, it will give me the 17, right? So it is the worst answer I can get, the worst maximum difference I can get, right? Correct. Kya Satyam? You're right. Correct. Now after that, we will be, but we know that we are not assured that it is the final answer or not, right? Because we have not done any modifications up till now. So to get the answer, we will have two variables, that is a small, right, and a max, or we can say a minimum or a big element, right? So by considering the answer, right, what you can do, the the answer you can get, or as Aditya said, according to him the answer should be, array of 0 plus k and array of n minus 1 minus k. It is right, right? So we are assuming that this can be our answer, right? Because it will work fine, but it is not sure that it is our final answer, right? So the first smaller number I can achieve to get my answer is array of 0 plus k, right? And the largest value I can achieve to get my answer is array of n minus 1 minus k. Largest value in terms of finding the answer, because largest value can be 16 plus k also, right? But it will fetch me a larger answer. So I'm talking in respect of the answer we have to find, right? Not about the terms of getting the maximum value, right? So the smallest value to reach to our answer, we can start from array of 0 plus k. Similarly, we can reach from array of to get the answer, the biggest value we can have is array of n minus 1 minus k. I hope till now it is clear to you, right? So after that, let us see how we'll be modifying, right? Now for the modifications, what we will do up till now, I hope it is clear to you. So this 17 will be stored as a temporary answer, right? Okay. So as we know that we have to update the minimum answer, because we can get all the possible minimum answer, and we have to take the minimum out of them. So that's why whenever we get a minimum answer, we will be comparing with this temporary value and update this temporary value according to that, right? So now what we will do, this was our array, that is 3, 9, 12, 16, and 20. Now we will be starting from this pointer, right? And we will iterate till this one. I will tell you why not starting from this, right? Because for this element there is no previous element, right? For this element 3, there is no previous element for it, right? And we want to compare the adjacent element. But if you started from this element and taking the next element, so you could have started from this, but in that case you cannot reach till end, right? So there are two cases you can take. In the first case, you can start from this one and compare up till this one, right? So if you start from this one, you will compare with the next element, right? But if you start from this one, you will be comparing with this previous element, and you will go until this one, right? I hope this scheme kind of thing is clear to you, right? Now what we will do, we'll be start iterating and implementing a logic and dry running it. So what will happen, we will start from this one, right? So I will, okay, so one thing you got, that the small number was array of 0 plus k, right? So in this case, the small number will remain what, 3 plus, here in this case, the value of k was 3, right? So in this case, the small number will be 3 plus 3, that is 6. And the large number or big number will be 20 minus 3, that is 17, right? I hope it is clear to you why I'm declaring this is small and this is large, because at first look, the answer we can, or the, the smallest value we can achieve to get our answer is 3 plus 3, 6, and subtracting from this one, as Aditya said. But it is not perfectly right. I hope up till now it is clear to you. Okay. Um, okay. So yeah, I hope you can move further. So moving further, now what I will do, I will compare this element. So for this element, as I said earlier, for this element, we are trying to make or get the maximum and the minimum, right? So I'm saying that what if I try to make this as the maximum element out of all these modifications? I'm trying to make 9 as the maximum element, right? Or I can say, no, I can say that, yeah, the correct thing is that I will try to make for this 9, right? For this 9, I'm trying to get the answer. So what I will do, uh, to the previous value, I can add some value, right? As I told that we can get the possible or the best answer from the adjacent elements only, right? For 9, the adjacent element are 3 and 12. So we'll look one by one for 3 and 12, right? And this, and the similar thing we'll be doing for each element, right? So for 9, right, what I can do, I can increase, okay, suppose if you have two values, or before moving the further, I will like to, enhance your more logic, so that or your intuitions, so that you can get the logic more clearly. Suppose you have two values, that is 3 and 9. Now you want to, reduce the difference between them by doing some modification. So what can be the possible thing you can do? You can subtract from the previous value, or you can add from the previous value. You can add something to the previous value, that is, if you add k to it, and subtract from this current value. That's how you can reduce the difference only, right? If you consider the number line only, right? This is the, these are the numbers in the number line, and you want to find the difference between, or reduce the difference between these elements. So what you will do, you will have to increase this element to something this point, and decrease this value to something to this point, to decrease the difference, right? That's what I'm trying to do here only, right? I hope it is clear to you. That's what I'm trying to do. So you can imagine this question on purely basic on the number line. That's why I'm drawing the number line again and again. So what I'm trying to do, I am increasing this element by k, right? And but one okay. So I increase it by 3, right? So it will become 6. This number is now become 6, and I will decrease it by 9 by 3. So it is again becoming 6. Correct? But now it will not give us the final answer. So the difference is 0, but it is not an answer. Why? As I said that we have to take the difference between the maximum and the minimum, but we are not sure whether 6 is the maximum, or this 6 is minimum, right? So, and that's why, because we have to still do modification on the remaining part also. That's why we are not sure whether 6 is the minimum or the maximum, and that's why we can't consider 60 as answer. I hope it is clear to you, because this is very important part here, right? So for considering that, or checking whether 6 is minimum, or this addition of 3 plus 3 to this value is minimum or maximum for all the values, for all other values, and subtracting a k from this will fetch me the minimum or the maximum value, that is 9 minus 3, right? So for checking that, what I will do, I have this large value, right, 17, and a small value. So for each number, I will be checking by adding and subtracting with this value. Suppose that, so what I'm trying to do, if I'm adding a number or something, a value k to a number, so it is the chance that it can become larger than this number, right? It can become larger than this number. It is not logical that we will compare after adding the value k to this number and comparing it with small, because this number, after adding something, the number will be increasing, right? The amount of that number, or the quantity of that number, will be increasing, not decreasing. That's why after adding a value to that number, I will be comparing it with large, in the hope that it might possible that if I add a number k, it might become the largest number, and if it becomes the largest number, it is beneficial for us because that largest number will be the adjacent for this number, right? Adjacent for 9, and if it is adjacent for 9, it will have the minimum difference among all the other elements that could be maximum. That's why we sorted the array. I hope it is now much more clearer to you what is the use of sorting here, right? And similarly, I will subtract 9, and I will subtract k or 3 from 9 in this case, and I will try to make it minimum. Why minimum? Because if it is not minimum, then we cannot subtract the modified these two values. So what I'm trying at each index or each iteration is that trying to make the adjacent element and the current element as maximum or minimum, right? Once it has become maximum or minimum, then I can subtract and get the minimum answer. And we are assured that since these are the adjacent elements, and if these become the minimum and the maximum, I will get the best possible answer, right? So that's why I will be checking for each adjacent pairs, right? That's what I'm basically trying to do. I hope now it is clear to you what I'm trying to do. Still you have any doubt, you can comment it down, right? Right, I hope the basic idea is clear to you. Now we will try to dry run, right? Now what I will do for this iteration, right? For this, I will increment the previous value by 3, or because by k, right? So this become 6 and this become 6 again, right? Now we know that the smaller value is 6, so I will compare this, because if something is reduced, then it is chances that it can become smaller than the smaller value also, right? In this case, the value of k is small, it is not becoming. But what if the k was, a very large value, then it might occur that after subtraction it might become smaller than this value. It might become smaller than this value, right? So that's why we are checking after subtraction whether it is becoming a smaller value or not. And the smaller value can only become if I subtract something from it, right? So what I'm doing, I will check. Okay, so I have a smaller and large value, right? So, and I will take another value minimum and maximum, and in the end I will update this temporary answer we took to minimum of temporary and maximum minus minimum. We will come to this point later on, but this is the basic idea what we are trying to do, right? This is the basic idea. So now first of all, we will try to iterate a loop, right? As we said that we are following the scheme in which we are starting from this one and comparing with the previous adjacent element, right? You can also do with starting from this one and comparing it with the next element, right? Both of them will write, but there will be some modifications you have to do for that. So I am starting from this first, and I will go up till n minus 1. That is the last index, right? Because for this last index, there is a previous value also available. Now I will have I plus plus, right? Now what I will do in this for loop is I will take a minimum value, right? Okay, I have a minimum value, right? So minimum value what will be? It will be the, I will denote it mini, right? So minimum value can be minimum of array of I minus k and this above smaller value, right? Because this is the smallest value we can get to fetch our answer, right? I'm saying it to fetch the answer because the smaller value can be 3 minus 3 also, but if I do 3 minus 3, so the difference will be much more increased with comparison to 20, right? So that's why I'm taking the smaller value as 3 plus 3 to get the best answer, right? Assuming to get the best answer. So I will compare it with small, right? Now again we will do for same as for the maximum element. Okay, so notice that minimum and maximum element is we are finding if I do the modification for this element, right? Again I will repeat, I'm trying to do for this minimum element, for this element I am trying to make it minimum and make it adjacent as maximum. If I'm able to make the adjacent element as maximum and this as minimum out of all the modifications we will do after this in all the remaining elements, then it is guaranteed that it will be one of the best answers, right? And similar approach will be followed for the other adjacent pair, that is for 9, 12, 12, 16 and 16, 20, right? That's my basic idea. So I will take here, okay, so here I will take for maximum, I'm trying to make the maximum element by doing modification. So I was adding the previous, this is denoting previous element, I was adding k to it, right? in the quest or in the hope that it can fetch me the maximum value or larger value than this one, right? So now I will compare it with large, right? Why I'm doing so? Because again I will repeat it again so that you can fetch it, right? Why I'm comparing or trying to make it large? Because until and unless the adjacent elements, both of these elements, one of them isn't large or the largest, or one of them isn't the smallest, we cannot subtract them, right? Because we can only subtract the largest and the smallest element and take answer from them, right? So that's why I'm doing that. And once we are done, we will update our temporary as minimum of temporary answer, comma, maxi minus mini, right? Because at each step I will be getting some maxi after updation and minimum, right? So that's the logic. Now let us dry run using this try or this logic we wrote down here, right? Now for this case it is clear, right? This case, for this case, it is the previous element is becoming 6, right? And this is also 6. So minimum element is 6. It is clear, right? So it can be the minimum value, no issues. But the issue comes when we are trying to make it this 3 plus 3 as maximum. But maximum is 17, so we cannot subtract, right? So you can see that the answer will not change, right? The answer will be remaining same, that is temporary, and maximum was in this case, in this first case, the maximum was maxi will remain 17, that is this value, right? And minimum will be 6. So answer will be updated to, now my temporary was 70. Oh, okay. So initially I took the difference without modification, right? So 13. So my temporary answer was, I will write down. Okay, I will take a fresh page. So my temporary initially was set to what? My temporary was initially set to 17. Now I'm getting the difference as 11. So my temporary will be shifted to 11. Cool. Now again we will move to here 12. Now for 12 I'm trying to decrease this value and increment the previous value. So by this you are seeing that I am trying both subtracting the each index and adding also, right? Because we don't know whether by subtracting or adding any element we will get the final answer. So that's why I am also subtracting and adding it. I hope it is clear to you, right? Now, or automatically it is being happening because each element will get its turn of subtracting by k and addition by k, right? Because once we were subtracting k from 9, but once we reach here we are adding k to 9, right? So in this manner we are trying all the possible combinations and approaches or ways, but some smartly, right? Now the next is 12, right? The next element is 12. So for 12, the maximum element, or let us talk about first the minimum element, right? The minimum element can be 12 minus 9, or what was 6, right? 6 because this 6. We will be always comparing with this small and large only, right? Because we assume that this is the smaller value we can get, and this is the largest value we can get to find our answer, right? I hope this thing is clear to you, and this argument, or this discussion is clear to you what I'm saying now. Right. So here this is minimum, and what I can get maximum, that is from the area of I minus 1, for it was, I can write it here, the area of I minus 1 for it was 9, right? So I will add 9 to 3 to it, and 17, right? I will compare. So here after comparison I can get 12 minus 9 is 3, right? And okay, what I did, 12, okay, so it will be here 3, right? Not 9, here it will be 3. So it is fetching me 9. The minimum is 6, right? The smallest element is still 6. Now the maximum element is still 17 here. So our answer will not change, right? So temporary will remain 11 as it is up till now. Now the next element was 16 here, and for it the area of I minus 1 was 12, correct? Now again I will find minimum for it. The minimum for it was it will be 16 minus 3, right? And 6. So the minimum will come out to be 6 and maximum will come out to be 12 plus 3 comma 17. It will remain 17. So the difference will come out 11 again. So it will remain as it is. Correct? So after that you can do similar for the remaining iterations also, right? So after you do all the iterations, you will get the answer as 11. Why 11? Let us now see, right? The answer will not change because the maximum and the minimum value after doing all the updations will be only the maximum value can be only 70 and the minimum value only be 11, and for these maximum and minimum value we can get the answer only, that is 11, right? So after the in the next iteration, our array of I was 20, right? And array of I minus 1 will be 60. This is the last iteration, right? So here the minimum will become 20 minus 3 and 6. So minimum will be 6, right? So after the last iteration, you will see that 6 can be the only minimum. But if there was some other minimum value, then you would have found some another answer, right? Some another answer, because minimum would have changed. But up till now, minimum hasn't changed, right? The minimum has remained the equal to smaller value we took in the initial phase, right? Now talking about the maximum element, the maximum element can become 16 plus 3 and 17. Here the maximum is changing, right? Here the maximum is changing, correct? It is becoming 19, but you can see the difference is 13, right? And it is greater than 11, our correct answer, right? 13 is greater than our current answer, so we will not update it. It will, the final answer will remain 11. So you can see from here that if the value of minimum would have been changed, right, so we would have got some answer, right? Because here in the last step the maximum value was changed and we got some answer, but it was greater, right? So that's how we'll be doing that up till now, because after that we will be moving to the coding part. And so that's why I want to ask, up till now anyone has any doubt in the logic, or you have any doubt regarding the approach, you can ask it so that we can move further to the coding part. Apart from that, one more thing is that the time complexity of this approach is big O of n only, of n log n, where n is the size y n log n, because we are sorting the array in the initial stage, right? That's why it is n log n. Now guys, one more thing here. Okay, I think anyone don't have any doubt. One more thing here is that before checking this minimum and the maximum, right? One more thing, can you guess what one more thing, or what more condition we have to pick to reduce the number of iterations or some, these computations? Because keeping that in mind, we were said after the modifications the value of the height. So because as we said that the question said that we cannot, after modification the height should not be a non-negative integer, right? There might be case, so basically, you know there might be the cases where if I subtract k, this array minus k can become negative, right? Correct. So to reduce the computations, what I will do, I will put a condition over here, a condition that if my array of I is greater than equal to 0, then only I will do that. Or I will say that I will say that if here I will put the condition, right? Here I will put the condition before this, iterating all these steps. I will put a condition that if my array of I is greater than equal to k, then I will only do that. Because why? Because suppose if my array of I is less than k, right? And if I do array of I minus k, then it will fetch out a negative value, but we are not allowed to do that, right? Right? So that's why we cannot take this, and that's why we have to put another condition here. I hope it is clear to you up till now. Let's now move on to the coding part. So this is our practice portal, right? I will be attaching the link to the problem statement in the description. Let us now move to the coding part here. So first of all, we have this. Let me clear to the function definition we are given. Right? So we have to return an integer value, that is the minimum height. That's why we are given the return type as int. We will be given an array, the size of the array, and the value k by which we have to increase or decrease the answer. So first of all, as we said, the first step was sorting. So we will sort the array using the STL function sort. Will sort, right? And due to this sort function, we are getting a time complexity of n log n only, right? After that, we took a temporary answer, right? Or let us say it as answer. The answer was array of n minus 1 minus array of 0, correct? Now we took a small value of array of 0, this array of 0 plus k, right? And we took a large value, that is array of n minus 1 plus k, correct? Now we have predefined everything, right? Now we will try to iterate as I discussed, from starting from 1 till less than equal n minus 1. So as discussed earlier, for each index I will try to find the maximum and minimum element, and I will try to make the adjacent elements, both of the adjacent element, that is I, array of I and array of I minus 1, as minimum and maximum. That's why, so that I can get the best possible answer. So for doing that, I will, first of all, the condition is that I have to check whether my array of I is greater than equal to k or not. If not, then I cannot do the operation of subtraction, right? Because it will fetch me a negative I. Now, what I will do, I will again take here another variable as int mini and maxi, right? Now, if array of I is greater than k, I will try to update and check whether my mini can be minimum value can be updated or not. For that, what I will do, array of I minus k, right, and compare it with small, right? And similarly, we will do for maxi, array of I plus k, right? Or sorry, array of I minus 1 place, because I'm trying to make the previous element as maximum. Guys, I hope the logic of making the adjacent element smaller and bigger is clear to you. Because we have done this because we can only find the answer after we have a largest and the smallest value. We can only subtract the largest and the smallest value. So to get the largest and the smallest value, we are trying to make the adjacent elements largest and smallest, because we came to the conclusion logically that only the adjacent values can fetch me the best answer, right? Why I'm repeating this again? Because this is the main crux of this logic or this question, right? That's why we have done sorting. That's because that's why I initially said that this problem is a pretty easy one, but it is hard to prove that why we are sorting and going by your intuitions, right? So yeah, after we are done this loop, I will try to update our answer. So answer can be minimum of answer comma maxi minus min, right? So that's it. And in the else part, if my array of I is greater than equal to k, so we can't subtract or do this operation. So we will continue, or we continue. What basically will do, it will make us reach out to the next iteration, right? So I hope, guys, that's it. And after the loop is over, we will return our answer. Right? So that this is the complete code, guys. I hope it will let us now have a look at it again. So we had sorted, we had an answer, right? And reassume the answer, or then we had a smaller value of array of 0 plus k, larger value of array of n, so it will be here n minus k, right? So that was that. So that's why I just inculcated the habit of rechecking my code, because there might be some typo error or any kind of error. So that's why before submitting, just try to recheck your code for any errors. After that, what I will do is, I'm checking for this loop, right? Array of I. Meanwhile, guys, you can comment down your your doubts, right? This is Penny is right? This maximum calculated is right. Now just try to submit it. So guys, I can see, as you can see, that it is a correct answer, right? So we applied it logically correctly. We devised or deduced the algorithm perfectly, and we have implemented it in log in time without using any extra space, right? So yeah, guys, that was it. So I will now take out your doubts, right? Okay, so we will spend 5 or 10 minutes taking out your doubts, right? So Abhishek is asking, सर मैं अभी सी पर कर रहा हूँ, कोडिंग कब से कर सकते हैं? See, Abhishek, you, if you're doing a C language, right? Learning a language and implementing and increasing your problem solving skills are two different things, right? If you don't know any language, you can still learn the logics behind that, right? Because learning the logic and solving a problem is different thing from implementing it. Implementation is the next step, right? You cannot implement or write down the code in any of the language if you don't know the logic behind it, right? So this problem solving and finding the solution is a different thing from learning a language. I hope it is clear to you. Now Vidya is asking that yesterday I solved this question. My logic was to add k to those elements which is less than k and subtracting k from those elements which was greater than k. After that, I find minimum and maximum of modified array and the subtraction maximum from 2 on why is it so? So, okay, you what you did, you just find minimum and maximum of the modified array, okay, and then subtraction from you find out the minimum and maximum of the modified array, okay, and then subtraction. So with that, you are because you are not sure why it is giving a wrong answer. What I feel is that once you modify the array, right? So it is you're not sure whether you will be getting the answer by subtracting element, right? By subtracting k from the element or adding from the element, right? So you have to try all the various possible combinations for that. I guess that's why your test cases are not working properly, right? And apart from that, if you still feel you can dry run the test cases, you can pick up the test cases, right, in which it is giving a wrong answer, and you can comment it down. I will surely look into it. In which test case, why it is giving a wrong answer, right? Anyone has any other doubts? Because after that, we can wind up this session. So I think yeah, no one has any doubt left. Okay. So yeah, guys, stay tuned to Geeks for Geeks practice. Happy coding. Stay safe. Bye bye.